Fantastic. Well, let's kick it off. Welcome, everybody. This is very exciting for me. I'd like to welcome you all to the very first UCLA Space Institute Conceptualization Workshop, which is happening, of course, today and tomorrow, June 2nd and 3rd from 4 to 5:30 p.m. My name is Jacob Bortnick. I'm a professor at the Department of Atmospheric and Oceanic Sciences here at UCLA. And the kind of top line, the takeaway from this workshop is that we are aiming to create an umbrella body, an institute at UCLA that kind of gathers and unifies all the disparate departments and institutes and centers and efforts that are related to space science and technology at UCLA. And we would like to make them very tightly integrated into the Southern California aerospace community, aerospace industry. And so we are inviting you, all our guests, the thought leaders of the Southern California aerospace community, to help us figure out how best to do that so that we are effective and we are the most relevant that we can be. So before I get into the meat of my talk, these efforts don't happen in a vacuum. I just want to thank a few people very quickly. The Institute's science planning team, that's the top line, myself, Vasilis Angelopoulos, Troy Carter, Ann Karagosian, and Marco Velli, and you'll hear from many of these folks in just a little while. Our friends from the Anderson School of Management, that's Fritz Demopoulos, Jeff Scheinrock, and Brian Newton. And Fritz Demopoulos is also on the Board of Trustees of EPSS. And of course, our administrative support, our Dean of Physical Sciences, Miguel Garcia Garibay, and his team, Christina Petroff, Kathleen Mickham, and the development team, Brooke Sanders, Alexandra Hood, and Jennifer Caulfield. And so I actually want to just quickly highlight Fritz Demopoulos, who in a single email basically outlined the whole concept of this workshop happening pretty much almost exactly as he outlined. And Dean Garcia Garibay, who said, this is great, let's run with it. And he threw his support and energy and resources. And so we're here today. And so I'm very excited about this. And what I'll do is I'll give you a little bit of background on our program, just a mission and a vision statement of what we're thinking and the goals of what we're trying to achieve in these next 2 days. And by the way, we don't have to finish everything in these next 2 days. It's just an introduction. I'm happy to follow up with any of you. I'm happy to meet up later on and discuss various items. This is just our first step forward. So let's see. Can you see that? I know that I have a bit of a lag. Okay. So just a little bit of a background on the UCLA program. What I'm showing here on the left is a graph of the number of space physics faculty as a function of time. This is time in years here. And this graph is meant to illustrate that UCLA actually has a very long-standing strength in space science. This goes back to before the space age. This goes back to the 1940s, even before at the beginning of the space era. In the 1960s, right over here, you see there was a large expansion in our faculty. We went up to about 9 faculty. And in the 1970s, this is from an external review we had last year. The quote is, it was the best program in the field. In the field meaning anywhere in the world. It was globally the top program as considered by this external reviewer. And that's at UCLA. As you can see, over the next decade or two, we had a decline in the number of faculty. We had retirements. We had, a couple of people passed, unfortunately. But in the current period now, there's a great resurgence happening. And this is what the graph on the right-hand side is meant to illustrate, this kind of the dawn of space industry. And we believe that it's time to invest in this rapidly growing industry now, invest time and energy and our resources, our creativity into figuring out how to make this really long-standing program very effective and very relevant for today. So here's the opportunity that I'm outlining. UCLA, actually, I think many of you know, but UCLA is very proudly ranked the #1 public university in the United States, right here in our own backyard in Southern California. It's not only the #1 ranked university, but it actually has a huge impact on first-generation students. We admit something like a third or a quarter of our students from community colleges. Many of these students are first-generation college students in their families. Many are underrepresented minority students. So UCLA as a whole is it's doing a good thing. It has a good mission. It really lifts people, from lower to the middle class. Secondly, the second part is that space science and technology at UCLA is very broad. We have so many different things going on. Multiple departments, of course, my own, atmospheric and oceanic sciences, Earth, planetary and space sciences, physics and astronomy. We have a national user facility in plasma science. We have mechanical and aerospace engineering, a ton of work done in propulsion research, and of course, our friends at the Anderson School of Management, who are now very interested in developing space as an industry, right, in entrepreneurship. The third point is that UCLA is literally surrounded by the aerospace industry. Aerospace is the single largest employer in Southern California, and Southern California is the heart of the aerospace industry in the United States. That's probably true for the world too. I don't have numbers on that, but it's certainly true in the United States. And there are huge workforce needs, especially at the present time. And the fourth point is that, again, referring to this external review that we had, the recommendation is that you have so many things going on, but you don't have a single face, a single entity, a single umbrella organization. So create it and streamline it and unify it, and make it something that's effective and relevant to the community around you. So this is the background on why we're here and why we're thinking about the Space Institute. So here in this very, very busy slide, you don't have to read everything, but what it's meant to illustrate is just a few of the activities going on at UCLA. So we have different departments like Earth, planetary and space sciences that I mentioned before, my own atmospheric and oceanic sciences. There are centers like this one in mechanical and aerospace engineering for propulsion. This is joined with Air Force Research Labs. I mentioned the basic plasma science facility. This is a national user facility. This is kind of on the map. It's extremely well renowned in physics and astronomy. Propulsion, I mentioned, mechanical and aerospace, the Anderson School of Management. We even have a Bruin, a group of students who launches rockets for fun. This is such a fun and exciting thing. So many different efforts, different departments, different centers, and the mission or the vision statement, which I'm working with right now, is that the Space Institute that we are envisioning will be an interdisciplinary and interdepartmental community of faculty, researchers, students, whose common goal is the elevation of space sciences, and will be done through the symbiotic interaction of fundamental science and exploration, which we're going to hear about in just a little while, technological innovation, so this is the engineering, this is the mission design, the instruments, and there's a pipeline to entrepreneurship, right? This creates the students with the ideas that go and create companies that eventually become, from small companies to big companies. Holistic education, UCLA is in the business of creating an educated, technically competent workforce, and there's a huge need around this. And communication with the public, which is always something that we can be improving. And finally, I think this is something that's very, very unique to us. I don't think any other university generally can boast being at the heart of the aerospace industry. And so a tight integration with the Southern California space community, I think, is really important. And I think kind of forms a major theme of the current workshop. So that's the mission statement. This is where we're aiming. This is what we want to do. So the goals of this workshop. So you can see the schedule for the workshop is outlined here. 10 minutes each. We're being very strict with our speakers. We're giving them 5 minutes or 3 slides each. Let's see if even I can stick to that requirement. But the idea is that if people are short, we can have a little bit of back and forth and discussion. And that's really where the magic happens, is we want to hear an exchange of ideas and what you, our guests, think of these ideas. So the first goal is to just communicate what it is that we're thinking and what it is that we're aiming to do with the Space Institute. The second goal is to look for partners in our mission and our vision. We would like to tell you what we're thinking, and if there's anyone we left out, if there's anyone that you think should really know about this, be involved in this, please do spread the word. Who should be involved is a question here. You can certainly let us know during the workshop or afterwards. We'd like to solicit your input, and we've left a lot of time that's open just for back and forth and discussion. So don't be shy. You can raise your hand under the participants box. I'm going to open my box right now so I can see any raised yellow hands. You can raise your physical hand on your video or just drop a message into the chat box. The idea is that you just make yourself heard. We're looking for opportunities for collaboration. Like I said, we are literally surrounded by the aerospace industry. There are labs, there are companies, there are small businesses. And people, I think, are looking for collaboration. Certainly we are. One of our goals, one of our main goals, is to create a plan going forward out of this workshop. What is the scope, function, and implementation of this workshop? How do we actually put it together in nuts and bolts and make it happen? Who will be the board of advisors? I know some people already here said, in capital letters, said, yes, this is an excellent idea. I believe in this mission. I think it's important. And those kind of people, I'm gonna probably tap on your shoulder and see if you'd like to be on the board of advisors. A fundraising plan, of course, we'd like to make this happen right. And so how do we raise the capital necessary to do this? And finding the educational plan that goes with this whole institute. One of our main products is an educated workforce, lifting students and creating the workforce of, I hate to sound cliche, but the 21st century, right? I mean, this is what we're doing here. So, so the next few days will be spent as follows, and I think, I'm over time. I did the thing that I didn't want to do, but can I ask for any comments, questions? Would anyone like to raise a hand at this point? Please feel free. Okay, if not, Mikhail, did you have something to add? Okay.
Hey, it's Andre. Just I don't know how to raise my hand here, but I know how to talk.
That's close enough, Andre.
Yeah. So it sounds like there's a kind of a unifying message with the Space Institute concept of, hey, here are all the capabilities inside of UCLA, kind of in one place, visible and accessible. And I think that's really valuable and important. But what I haven't heard, at least not yet, is what is the Institute planning to do, right? Are there some key actions? And then, hey, the Institute will be successful when, these three things happen over some period of time. Like in 3 years, if we do these three things, this is a win. And you're probably going to get to some of that, but this is kind of how I'm wired.
I think that's a great question. I don't know that I have a single answer to this, but it's almost like we have all these disparate efforts, and many of us who work in isolated groups hardly even know about other groups. Certainly before I started this effort, I had no idea about many of the efforts in mechanical engineering. I knew only some about EPSS. The idea is that if you're looking to develop missions, concepts, ideas, you know right away who's working at UCLA, and just having that accessibility to different kinds of people allows you a huge lever, a huge range of opportunities. And this is just on the science and the research side. We haven't even touched the educational side. And so what I'd like to see is missions and ideas and science that just wasn't possible before, that's enabled by this kind of very friction-free kind of collaborative institute. That's one answer. Does anyone else have a different answer?
I would say that there is still a lot to listen. So why don't we just keep going a little bit more, and then we can reconvene and reanalyze.
Good idea. So let me stop sharing and hand you over to Professor Marco Velli.
Marco, you're muted.
Hello. Anyway, I'm Marco Velli from EPSS. I will not go back to the previous slide, which was essentially useless. So I thought we start discussing space. we should say where we are. And this was a kind of a humbling aspect, at least before we start thinking of ourselves as the center of the universe once again. So we're running around a star that is running around an average galaxy at a kind of an average distance. We're surrounded by an extremely interesting dynamics of cold molecular clouds, hot plasma emitted from other stars. And then we go into the detail and look at our own star, and I'm just following the arrows here from the sun and the galaxy to the local medium around us to our sun. We see that we are sitting, all our planets are sitting inside this bubble, which is excavated by the sun. And it's called the solar wind, and the bubble itself is called the heliosphere. So what is the heliosphere? The heliosphere was discovered essentially through space exploration. I would put that about 64 years ago with the Sputnik and then other in situ measurements. But it's essentially an aspect which comes from the fact that we are sitting in the outer atmosphere of our star. Now, this is conjured by the fact that the sun does not end at the photosphere because it has a magnetic field. Now, the sun that we're used to, that gives us life and heats us, provides life and stuff, and only a really small, tiny amount of that energy is captured by the magnetic field and redistributed. But the consequences are enormous. Some of that energy, which comes from convection on the sun, less than 10 to the minus 5, 0.1% at maximum of the solar luminosity, gets focused and produces explosions that are of the orders of hundreds of millions of hydrogen bombs, of the worst that we've ever built in the lab, and propels this matter into what we call now interplanetary space, which is what we visit and we explore. So we haven't understood really pretty much anything of this plasma, as we call it. And this plasma is really a guiding a stone or a Rosetta Stone for generally physics and astrophysics. It's a multidisciplinary endeavor trying to understand this. It requires all sorts of types of different knowledge. And of course, the consequence of this magnetic field is the presence of a ubiquitous solar wind that not only hits the Earth and therefore astronauts that might be in space, but it creates physical phenomena surrounding the bodies inside the solar system. And presumably this will happen for all stars in the universe and for all other planets around other stars as well. So understanding how this stuff works is really important, and measuring how this stuff works is very important. The Earth itself is protected. Yet what you're seeing now is the really explicit illustration of what a solar storm does in terms of energetic particles. It can destroy satellites and things. And so we're at the forefront of trying to understand how these things work. So what do we do with space exploration at UCLA? And what has UCLA been doing? It's been participating in producing spacecraft, multiple spacecraft, ground arrays at the Earth to understand the case of what's going on in the Earth's magnetosphere, which is continuously impinged on by the solar wind. Study what happens around the moon and moons of other planets themselves. And the goal, of course, is to understand the solar system, its origin and evolution, and in general, how stars and planetary space environments operate. And as I said, this is a really Rosetta Stone for astrophysics, because more and more we learn from remote observations of other stars, galaxies, and so on, that some of the basic fundamental physics is here at hand in our lab. So this requires theory and modeling, the development of instrumentation and new observation. And in theory and modeling, we have all sorts of things that go from theoretical old concepts and standard physics to new numerical modeling. The amount of data that's coming down is immense, which requires the use of new methods, artificial intelligence. And so it really creates an environment for multidisciplinary exploration. UCLA has taken part in a lot of this exploration and continues to take part. Let me just mention that a few of the instruments that were developed and or spacecraft that were developed here, Themis, Artemis, a CubeSat, Elfin. We were a fundamental part of Cassini, of Galileo, and other missions that were trying to understand the magnetospheres or the induced magnetospheres from the solar wind to other planets that create the environment around which the planets live and survive. As I said, the central engine of this is poorly understood, and we have two new missions flying now, Parker Solar Probe and Solar Orbiter, that over the next decade are probably going to completely revolutionize our understanding of how this stuff works in the heliosphere. And we are, the researchers at UCLA are an integral part of this kind of exploration. An example of the future is, of course, Europa. We're searching for life on other planets. This is another important thing. And Europa has an underwater ocean that was discovered thanks to some of the instruments that are developed to study the plasma in space, for example, magnetometers. And so UCLA is going to provide magnetometer on Europa Clipper, and that will provide some of the fundamental physics of that kind of research as well. I've been going extremely fast, and I'm here at my conclusion. I just want to say that UCLA is a protagonist with over 30 researchers in space physics in what's called the Heliophysics Systems Observatory, which is essentially the NASA constellation of satellites that have existed and to explore the various facets of our heliosphere and of our solar system intended in a generalized sense. Clearly the potential at UCLA to explore by integrating all facets from theoretical modeling to numerical simulation, to the development of new instrumentation, to the development of new flight concepts, to the development of new ways of transmitting the data that has to get back to Earth. All these can be united under a single umbrella, and I think that's what the goal, one of the important goals of the Space Institute is going to be. Thank you.
Thanks, Marco. Any questions or comments, Marco?
I see one chat here. Oh, thank you, Jacob. You were explaining what the photosphere is. Yes.
Yeah, thanks. I think let's transition to Vasilis. So in the meantime, I'll just quickly add that I think at least some of my senior colleagues tell me that UCLA has had a magnetometer pretty much on every major NASA mission that has been flown, which is kind of a remarkable, almost mind-blowing achievement to think about.
Great. Can you see my screen?
Yes.
Can you hear me okay?
Yes.
Yes.
Great. Well, thanks for the nice introduction, Marco. I have less to talk about. I can cut my time. I'd like to discuss how the CubeSat revolution fits new models in educational experiences and how that fits very nicely in the Space Institute we're talking about today. First of all, humans are explorers. We're constantly looking to expand our horizons, and we're driven by curiosity, and we're in awe of the world's beauty. We strive to study and visit places far beyond our home Earth, and that inspires everybody. Here at Earth, we're motivated by space weather that you heard from Marco earlier. It will be of concern to us for a long time. Once was only of concern for national security and astronauts. But now it affects our entire society because we depend increasingly on spacecraft for communications, for transportation, weather prediction, navigation, and so on. So protecting our assets, our astronauts and our space tourists in the future requires a reliable space weather monitoring forecasting system, and that's only growing. Much like meteorologists require space weather stations across Earth's surface, now in the future we'll be requiring distributed satellites to monitor and accurately predict the immense energy that comes from space, and it is covering such a vast region of our Earth. So we need to pixelate how exactly it works and how space weather fronts move about to affect us here at Earth. So until recently, such an endeavor was prohibitively complex and it was expensive, but now space science and technology have reached a turning point where powerful but cost-effective micro spacecraft constellations are becoming feasible. And they provide cost-effective means to monitor and study and predict space weather, as well as new opportunities for conducting science and training space scientists. But beyond Earth, small satellites can expand the capabilities of flagship missions and address cutting-edge problems that would not be as effectively done from large mission platforms. For example, studies of water or magma ocean interiors of Jupiter's larger satellites, or the interior composition of asteroids can be much more effectively done by a magnetically clean CubeSat that form instead of a multi-purpose large satellite that combines imaging and radar studies with magnetic sound. That's 3-ton satellite, and imposing magnetic requirements on that can be extremely onerous, but doing it from a CubeSat, easy. So small satellites allow much more than just cutting edge science to be done, it enables such niche science, and it enable also constellation class missions. In fact, small satellites are a disruptive innovation. They create new markets and a new value network, and are bound to eventually displace established firms, products, and alliances. They can also get to many places nowadays because of the existence of new ways of taking them from the first release into space to further away from the primary payload and put them on unique orbits that they can contribute to that niche science. But small satellites are also uniquely suited for educational models of research universities like ours in the future. So formal education can now happen online, but honing students' critical thinking goes well beyond mere knowledge of facts and homework problems. It requires students to interact as they would in a real-world environment, and to practice those skills in a multidisciplinary team that they will experience out in industry. So when education is conducted hand in hand with research and with student participation in such projects, research projects, it has the most value to the student and the most value to the future employer. So small satellites, in particular CubeSats, enable such teams to form in an educational setting, protective setting, where scientists and engineers get together to formulate and to address cutting-edge science questions. So the setting is as real as it gets because they address cutting-edge problems. Training students in such situations where they're expected to push exploration boundaries is unforgiving, but it's also exhilarating. So students will work hard at it, they'll experience peer pressure, and strive to establish reputation and name recognition. In the end, both science and education benefit from this. It is precisely what industry and graduate programs need. And it is precisely what the nation needs in order to attract and to retain students in STEM fields. So for this reason, establishing a program like this enables innovation with real-world challenges in a protective setting, under the guidance of mentors and under the auspices of the faculty and academia. And this is the best way of training the next generation of space explorers to serve industry and the nation. So I think that's how the Space Institute can serve the Southern California space industry, research, and education at the same time. Thank you.
Thanks, Vasilis. Any questions or comments for Vasilis? I think, Vasilis, the cost of a CubeSat, would you say, was it about a 1% of the cost of a full-scale mission?
Depends on the mission, but yeah, CubeSats go for about $1 to a few million. They can be constructed as such. That's the value that NASA places in new programs that it funds. Mm-hmm. And it's, I think, realistic. And so not just academia, but R&D organizations can participate. Mm-hmm. And in fact, it is extremely important for everyone to participate. For them, for large organizations, it's important to test in flight rather than spend years mm-hmm. and millions of dollars to prove a concept by laboratory testing. Just fly it. Mm-hmm. So for them, it's also very valuable. Yeah. So yeah, a few million.
A few million.
And it's about, 100 times or more cheaper than other, standard NASA missions.
Mm-hmm. And on your recent Alphen CubeSat mission, I forget what the number is, but it's some staggering number of students that helped to make that happen. And I'm sorry I'm dominating the questions here. Please shout if anyone has any questions or comments. But what is that, the number of students that were involved?
Alphen has been going on for 10 years, and 5 later years, it was funded by NSF and NASA jointly. The mm-hmm. previous years, it was internally funded. So throughout this period, 250 students have gone through. At any given time, there were 40 students that were participating. So we've seen quite a few generations of students that now are at SpaceX, at Lockheed, at Boeing, at other organizations, and they're very proud of their heritage and very thankful of the education they got.
Mm-hmm. Yep.
Yeah, Jacob, this is Richie Wers. I would like to say that Vasilis didn't do a sufficiently good job bragging about the incredible work that he did, particularly in Elfin. And when I first got to UCLA, he reached across campus, literally came to my office and said, "Hey, I think I can use you to help me get some aerospace engineers and build this CubeSat." And I said, "Who is this guy? This is a great idea." And it was fantastic. I mean, it was something that I'll give a talk tomorrow, but just in light of Vasilis's talk, I thought it was a magnificent thing that he did, really bringing engineering over to his side of campus. And so many of my students were very inspired by Elfin, and it played beautifully into our space systems and space technology curriculum. So it was just wonderful. So I'm going to brag more about Vasilis tomorrow when I talk, but I just wanted to interject that.
Well, thank you, Richie, and here's to more to come.
Yes,
More.
absolutely.
Yeah.
I see Carol Raymond has a hand up. Carol, would you like to speak up?
Yes, thank you. Vasilis, you've done a great job of demonstrating how powerful these small set constellation missions can be to do real science. And but there are challenges to applying that model farther out in the solar system, where mission times are longer. There are other challenges. So in your view, what are the major challenges to this becoming routine across the solar system?
Well, there is communication, first of all, but I think, and power when you go further out. But those, I think, are changing. Now, it is possible to communicate with S-band on these things and on CubeSats. And because you're, in interplanetary space for a long time on the way there, or you can afford small data volumes as long as you transmit over a long time, and you're not too far away, you can do it. So I think because of the sort of the revolution that's happening, and so many companies developing components for CubeSats, it is suddenly becoming possible to take one of these, swing them by the moon, and take them then to another planet with the help of JPL.
Mm-hmm.
So challenges, other challenges there. I think it's entirely feasible, Carl. It can be done.
Yeah, and that's one thing that we're doing, Vasilis, as a student group that broke out of Elfin with Bruin Space. One thing we're doing is developing very high efficiency micro satellite propulsion that can actually do cislunar and interplanetary missions. So that's what gets you there, right? You need that delta V to get to the destination.
Yeah, it will be a stepwise approach. We cannot have enormous data volumes and send images every second, but we can start from magnetic fields. Easy. You don't have very many, much data volume when you're talking about magnetic fields, and do really cutting edge science and develop new technologies to do more. So I think it's entirely possible to move in that direction now.
Just to jump on that point further, I think this is the point of integrating science and engineering closely together is that, we in the science world say we want to go further. We want to go to, further away places. And, it's up to the engineers to kind of say, well, what technologies do you need to develop to make that happen? I think the science kind of pushes the technology in that sense. So the challenges are, what do the Buddhists say? The obstacle is the way. The challenges are the good things.
And let me add to that conversation. And I think one of the things I love to see happening are these type of conversations regularly in the Space Institute, an umbrella under which we meet regularly, where we have actually maybe something like an explorers club, where we bounce these kind of ideas around and ask what technology we have, where can we apply it, and what's needed for tomorrow's applications. That conversation right now occurs, but only in very small groups. And it'll be nice to have a wider audience in which these ideas are shared.
Absolutely. Krishan, since you have the floor anyway, and it's you next, would you like to just go ahead?
Sure. I'll start sharing the screen. So first of all, I want to thank Jacob for giving me this opportunity to tell you about a resource which is very unique to UCLA, which is the research community. He invited me to talk about them. Also, Marco and Vasilis have already given a fantastic overview of the field itself and UCLA's place in it, the kind of work we do. So that will make my talk much easier and faster. So I want to begin with who we are. So UCLA is very unique. We have a space program, unlike most other places, where you don't just have a model of a professor and graduate students doing the research, but also independent researchers who work in at all kind of projects and work all not only lead missions, but also are part of many of the missions that come to us from either NASA or by other organizations. So there are about 70 of us distributed between EPSS, atmospheric science, and physics department. And together we bring more than 20 million research funding. And what makes the common thread here is we all work with space and plasma around the solar system bodies and the universe. The researchers are world leaders in their respective fields. And our research program, as Marco and Vasily said, is the envy of other educational institutions. We are funded directly by grants from NASA and NSF, but we also have close collaboration with other centers. We work with APL, JPL, Goddard, and the skills we have are multi-dimensional. We work in plasma theory, data interpretation, both big data, AI, um, and one of the great strengths of this department is we perform simulations, plasmas and magnetic fields. So here I'm showing you 4 different planets and their magnetosphere. Mercury's magnetosphere in the top left box, which will fit into a tiny region of the Earth's magnetosphere, which itself, if you go to Saturn's magnetosphere, fits in a small region of that, and which is again a much smaller magnetosphere than that of Jupiter. So Jupiter magnetosphere is about 1,000 times bigger than that of the Earth. And our researchers study all of these objects. So what we do, Marco already told you the many different areas where our strengths are, and we have researchers which work in all of these areas. So for the Earth's magnetosphere, there's a large group, maybe 60, 70% of the research group, which is looking at flow of mass, momentum, and energy carried by the solar wind as it travels through the Earth's magnetosphere. And it also, that interaction creates these Van Allen radiation belts, and we like to understand how they operate, how they are generated, and what their effect is on other assets like humans or spacecraft in space. We do studies of the sun. There's a large group which works with Marco and who are trying to understand the magnetic field of the sun, how solar wind is accelerated. Then planetary magnetospheres, which I'm showing an example of Jupiter's magnetosphere. It's so the questions there we ask are, how is it generated? What kind of radiation environment it has? What can we learn about this magnetosphere and apply it to the Earth's magnetosphere, which we inhabit? Mark also mentioned that we have been able, actually UCLA has pioneered a technique using magnetometers, a technique of electromagnetic induction that we are now using in solar system bodies to understand conducting regions inside these bodies. And most of the time, these conductors are subsurface oceans like that of Europa. There'll be future missions, maybe to Triton, to Ganymede, once again, which are suspected to harbor subsurface oceans. We also have in the physics department a laboratory plasma group, and they study laboratory plasma's instabilities. And these are not only uh, uh, needed to understand how the universe operates, but also if we are tomorrow going to have fusion reactors, how you can contain large amount of plasmas in laboratory so that you can have a sustained nuclear fusion device. So some highlights of some big ticket projects that are led by researchers. You already heard about Europa Clipper, where Margaret Kivelson is the science lead, but there are 4 or 5 of us who are also co-eyes on that mission. We will build a magnetometer, and our task is to determine the location, thickness, and salinity of Europa's subsurface ocean. Then Bob Strangeway, another senior researcher in the department, is heading TRACES, a magnetosphere, which is again trying to understand the origins of solar wind and how it affects the Earth and its magnetosphere. And then Ying Juan Ma is leading a Mars mission, a magnetometer on a Mars mission, which is trying to understand how solar wind momentum energy flow through Mars magnetosphere and how it affects both the atmosphere and climate of Mars. So I will end by saying that um, the most of the research engage in sponsored research and are most of the times confined to their area of expertise. However, it's an untapped resource. They are available for teaching, and this would help the research community itself by providing another source of funding, which adds to their funding security. But also it really is a win-win for the university as well by enhancing the range and number of classes that can be offered to UCLA students at all levels. And if we are going to go in this direction, um, it will enable the creation of professional master's program for our industry partners. And you have this untapped research, uh, researchers, top-notch researchers who are good at both research and teaching, who could actually help you educate that workforce. We are also available for other industrial partnerships. If there's an umbrella organization which is in touch with broad industry. So we could, for example, help other partners in giving knowledge about how we can protect our spacecraft and astronauts from space radiation in the Earth or Moon or Mars space environments, where we are planning future manned missions. So we excel in the field of space weather prediction, and we could really, through our simulations, through our knowledge of deep space, we could really help these future missions and other agencies who are working in that area. One of the things that is occurring now of great interest is all the space junk that is present in low Earth orbit. And actually there's a very good solution using the Earth's magnetic field and the Lorentz force that you can create either by flowing some current through some objects or through having tethers. You can use that technology to create space junk. And there will be many of us who could help in that type of work. We are also available to consultancy to aerospace industry. You know, we of course understand space plasma processes, but also many of us are developing these instruments and would love to collaborate in developing more of these for both space and planetary research. And finally, we are available to partner in future calls for both Earth and planetary explorations. So this is an untapped potential, and I will encourage all stakeholders to use it to both have an institute that we can support and an institute that supports us as well. Thank you.
Thank you, Christian. Can you stop sharing for a moment? Jacob, if you don't mind, I'd like to take just a moment to, as we transition in topic here. For those of you who haven't met me, my name is Miguel Garcia Garibay, and I'm the Dean of the Division of Physical Sciences. And I just want to stress that the development of this institute, and in fact, a divisional investment in space science and technology is one of our strategic areas. So the Division of Physical Sciences is fully committed for this to happen. So one of the, to answer a little in part the question of Andre earlier is, we view ourselves basically as taking advantage of our science and technology innovation and finding ways to interface that to the Southern California space enterprise with the industrial community that works on this area, right? Now, the best way to interface science and technology innovation with the commercial enterprise is naturally, through entrepreneurship. And that's how the relation with the Anderson School came about. So I just wanted to stress the fact that this is a critically important, objective of the Division of Physical Sciences at UCLA to support this group and to really take advantage of the current moment.
Thank you very much, Miguel. Yeah, Mark Davidson.
I apologize. Thank you for the invitation. I am Mark Davidson. I'm with the Jet Propulsion Laboratory, and I work in the offices of Space Technology Partnerships, and I also am the overseer, in essence, of the NASA Small Business Innovative Research and Small Business Technology Transfer programs, which that funding that we do through NASA for those projects that are managed locally at the Jet Propulsion Laboratory falls under my purview. I just wanted to point out there's several other space institutes, of course, Caltech with Keck, the Carnegie Space Endowment, et cetera. So one question is differentiation. Then in addition, the California State University Northridge just stood up an autonomy center that I know that our NASA center at Armstrong, we used to call it Dryden, out in the desert, has some involvement with in the area of autonomy for terrestrial vehicle systems. Think of uncrewed air systems. And then in addition, with an organization known as the Starburst Accelerator, I've just been recruited into a cohort that is being co-led. It's called Scale through the UCLA School of Engineering and the Starburst Accelerator Program. We have, I believe it's 7 to 8 small startups that are space technology businesses that are actually going through call it a boot camp of sorts. And it would be great if Anderson could also be brought into that community to talk about the entrepreneurial side of space, because as you know, the best way to be a millionaire in the space industry is to start with $1 billion. So it can be a very difficult and trying enterprise. So with that, I do apologize. I do have to shove off and I won't be able to join you. I also want to give a nod to my colleague, Andre Dumont down at Aerospace Corporation. We're also engaged in an organization called the Space Ventures Council, which is trying to create some level of community for small space business startups in the Southern California geography. So I'll leave it at that. Glad to participate, glad to help, glad to come back and meet with members of the faculty to educate you all on how to become engaged in the small business innovative research. And in this instance, the STTRs, which have to have research institutions engaged in the project with the small business. So we'd be glad to come back and talk with you all and have some level of participation, not only from the Jet Propulsion Laboratory, but also as a UCLA alumni, class of 1980. So physical sciences, geography, shout out to Greg Oken over in the School of Geography. So thank you all.
Thank you, Mark.
Thank you, Mark.
Thanks, Mark.
I think this is a great segue to Brian.
Yeah, Mark, sorry to lose you there. That was a great intro, and I'm not going to put a slide up. I am a big fan of UCLA, and more specifically of UCLA Anderson. I see Jeff Scheinrock there, so shout out to one of the top deans at the business school there, who heads up, I think it's 700 students who finish up their capstone projects doing entrepreneurial startups, venture initiation. So Jeff, I know you follow me. I don't want to steal your thunder on what can happen there. But back in '95, when I came here and I graduated in '97, I started up an incubator with the folks out of the Price Center at Anderson. And that was unique in the sense that it was the first time that the university, because the Office of the President at UC System had said, the UC system can take equity instead of burdensome licensing fees for the transfer of technology. And so we jumped all over that when we got that letter and saw that we could do something collaborative with UCLA and tech transfer. And, you know, there's some Caltech people or Caltech affiliated people here, and it just made me shake my head that Caltech is 1/10 the size of UCLA, but was doing about 10 times the volume of sponsored research. UCLA obviously is a big grant recipient. So with that as a context, we actually started getting the students to come in who had 5 years work experience. Some of them were chemical engineers, some of them were CPAs. We would build teams. We would work with the faculty and the researcher from all across the UC campuses and help launch businesses in conjunction with tech transfer. And we ran into a bunch of brick walls. I was naive about this, having come down from Silicon Valley and grew up with that model, and saying, why can't this be? Well, there's certain things that happen, and there's certain barriers like the siloed systems that I heard Miguel talk about. But the whole reason we're here is for collaboration and to figure out how we can establish some trusted relationships and begin to, you know, accomplish the goals. I think everybody here is probably passionate for the state of California. They're passionate about the mission of UCLA to be able to attract and retain great talent and the next generation of people who can lead us forward, the creation of jobs. So there's this natural collaboration that happens at the university. And so I'm here to talk about, you know, how we can work with the venture capitalists. Having been in venture capital alongside Jeff Scheinrock 2 decades ago, and having been an entrepreneur, I know that the university is an absolutely essential part of the ecosystem for venture initiation, not just the business school, but the faculty and researchers who aspire not only to stay as faculty and researchers, but go out into the private sector, launch companies, and do that collaboratively with the UCLA administration in a way that works for everybody. And so I think we've made great progress over the last 20 years to do that. And, you know, there's some people on here that I want to highlight who come from, and by the way, thank you to all the researchers that came on. I am by no means that caliber, and so I'm honored to be in your presence. But I am a connector of people and really, really love the idea of how we can initiate ventures, get them funded, and launch them for the purposes of creating jobs, for establishing a robust economy. How many people out here are investors, have been investors in early stage companies? Can it maybe just, if you got your camera on, raise your hand? You know, are there 5, 10 of you? Okay, how many have started up companies, whether you failed or succeeded? How many of you have taken that plunge and started up a company? And I'm looking across, and there's a good group of those. Laura, I'm so glad, Laura Crabtree, I'm so glad you joined. You know, I know that we got you in touch with Fritz, and you left SpaceX, and you were aspiring to be entrepreneurial. And, you know, that's a big leap that you take, a big risk to leave maybe a safe and cozy environment where you are at the front of your field, now doing something pretty exciting. But just to highlight that very quickly, she collaborated with a UCLA Anderson graduate, Max, who became the COO, and Laura became the founder of Epsilon, which is the operating system for spacecraft operations. Laura is at the forefront of her field for doing this. And so here she is as an entrepreneur, having received venture capital funding for the first time from a local venture capital fund to get her business launched just in a matter of months of coming out with that concept. So we sit here with people who understand the science, who understand you know, the university administration, tech transfer, venture capital, venture initiation, and then not to leave out the people who are in corporate venture, those large corporations who really do look to see what the cutting edge technologies are and need a vision going forward as to what's going to change in the 5 or the 10 or the 15 years as they look out on their strategic horizons. So I know we have a bunch of those very qualified people. So rather than say, hey, you know, look what this can become, I think, you know, Fritz and Jacob and Jeff and Miguel, who were on the early calls, the idea is let's get the conversation going. Let's establish a rapport. Maybe we end up with breakout groups, but to sort of bring it back to the idea of what can you know, the venture capital community do here. Venture capitalists are great. You know, Fritz is a current venture capitalist, having been a very successful 3-time entrepreneur, doing it under very difficult circumstances, you know, out of China, and doing that successfully. Now he's turned around and become a venture capitalist. One of the things that Fritz started doing was he started listening and talking with science fiction writers because he wanted to understand the future from those people, to be able to understand how he might be thinking about making investments. So the idea of at the front end of this, of these great researchers and scientists who are talking about some of the cutting edge stuff and how that actually then will bleed into our society is really important from a venture capital standpoint. And so I think that, you know, the more we can listen to venture capitalists and the more they're willing to listen to what's really bubbling up and percolating out of the pure research that's going on and seeing where they can help. And one of the nexuses that I heard Christian talk about was the idea of available public funding of grants. Now, most venture capitalists are very interested selfishly in being able to help facilitate that process. And the reason is that's non-dilutive to their own equity investment in the companies that they can launch, but they need the research partnerships to be able to do that. And if these are massive operations, if we think like Tesla or SpaceX, they require a lot of that type of capital, and they require a lot of that funded research to happen. in order for something to be successful on the commercial side. So I see that VCs in at the early stage, and even more broadly, downstream investors, investment banking and so forth, are really interested in being able to figure out how we create that nexus. Because the goal ultimately becomes attraction of great talent, retention of that talent, a search for opportunities more broadly. If you think about that, opportunities for greater research, opportunities for something that we can take into the commercial markets. All those things require all of us to sort of be talking in an interdisciplinary way and reaching across. So I think it starts here. The last point I would make is that we're all sort of searching for understanding and collaboration and trust to be able to fulfill that UCLA mission. And that would be, hey, how can we, contribute to the economy? How can we create jobs? How can we create that virtuous cycle where those jobs then lead to the next generation of people who can come be students in the classroom and really be at the cutting edge of new research, that things that our generation doesn't think about. So that's all I wanted to say. Maybe, Jeff, I think you might be up next, or actually I saw Jonathan as well. So I'd be very interested to hear the perspective of the corporate venture and how you guys see collaborating and maybe creating some goals around this meeting.
Thanks, Brian. It's really neat. It's very exciting. Any questions or comments for Brian?
And sorry to put you on the spot, Laura, but maybe 2 seconds if you want to give a little commercial here.
Mm.
It's not a problem. Hi, everyone. I'm Laura. I did not go to UCLA, but I do love UCLA and all of the general talk surrounding, aerospace and bringing up this industry, because as you stated in the beginning, this is really the hub of the space industry. There's little pockets elsewhere, but Los Angeles and like the surrounding areas, even down to Orange County and up to Santa Barbara, this like pocket of what we have here is really magical, and so many great things are coming out of it. And I think, all the things that you guys are talking about are wonderful. And I'm really excited to see what comes out of this. I think it's really great.
Thank you very much. That's neat.
Yeah.
Okay, if there's no other questions, shall we move to John Arnberg? John, are you ready?
Yeah, let me get my slides up here.
All right.
Everybody see my rather plain slides here? Okay, so I was asked, there, now you saw the whole presentation. I was asked to discuss collaboration with industry. I'm going to address this problem wearing what I'll say is all three of my hats. Number one, very proud Bruin alumnus with degrees in physics and engineering. Long-term, lifelong Southern Californian, and my corporate position, which is listed there for identification only. These are my opinions, not the opinions of my employer, past, present, or future. So in terms of cooperation with industry, it's been stated, I don't think it can be overstated, that aerospace is a large part of the California and Southern California economy. And to put it quite bluntly, it runs on people. There's always a demand on staff. This is not only staff that is technically equipped to handle the problems of today, tomorrow, and the day after tomorrow, but also is equipped for living and staying in Southern California so that they can enjoy long, productive careers. So recruit locally, grow them locally. Like myself, like a lot of my colleagues, will grow up here and will stay here because the job and mom are here. The other thing I wanted to mention, this has been stated and I'll restate it, all projects in space are highly interdisciplinary. And I believe it's worth saying that more than the usual suspects. It's not just engineers and scientists, although that's nice. But I've spent over 12 years on James Webb. We have lots of people like English majors that work our communications aspects, and contracts people, and managers, and even a lawyer or two, and folks that deal with export control, and all of the things that are needed to make these very complex, amazing systems, whether they're large or small, go. Next set of bullets, the UCLA Space Institute is a great idea, and it's vastly overdue. When I was talking to Jacob, I said it's a pity that I'm not here to celebrate the 50th anniversary of this institute. But now is a good time to start. So I think it's worth saying that no matter what direction this institute takes, there's ample room and likely great enthusiasm, not only for myself, but all of my colleagues, both at Northrop and at our competimates throughout Southern California, for this kind of institute, particularly if it's designed for the mutual benefit of the entire community. Okay, industry will be excited and enthused and want to engage for many reasons, from the obvious to the very subtle and not so obvious. And so I think the specific engagements are really going to depend on the direction of the institute. So to give an idea of how that might come out, you might not know this, but I have a time machine, and I'm going to invite you all in it, and we're going to jump ahead to the 10th anniversary review of the UCLA Space Institute. So here's the Institute's 10-year review. This is kind of the brag sheet before the individual leads get up and describe. So that there was a plethora of missions and instruments flown for Earth science, heliophysics, astrophysics, planetary, engineering, and maybe even a few other missions, and we'll get to those ideas down below. Technology, both government-sponsored, company-sponsored, and maybe even university or private funding sponsored. These are individual technologies such as specific materials, radiation resistant, low CTE, coefficient of thermal expansion materials. That is, things that don't change shape or size when they change temperature. Propulsion, big data, highly efficient communications. The list is truly infinite. One of the proudest achievements of the UCLA Space Institute is the vast number of students educated for the 21st century workplace. I shared with Jacob, and a couple of my co-authors are on a short white paper I wrote for the Astrodecadal, talking about the strong need for scientists and engineers that speak a common language in order to advance the field. Like I said, this business runs on people. So interdisciplinary education and exposure, not just for science and engineers, but for people in other departments, geography, English, business, law, etc. An institute like this could also have very strong ties to our feeder schools from UCLA, the community colleges, assuring UCLA fulfills its mission to support all the students in the LA area and greater California. Great achievements in academic studies, the study of future of spacecraft and space technology. This is modeled on the Air Force's Project Forecast from the early 1960s that predicted what the Air Force of the 1980s and beyond would need, and that's where some of the amazing airplanes came from this deep look. I happen to know because my father was assigned to that project when I was about 3 or 4 years old. Complex system design. How do we actually cost and temporally efficiently design complex space systems and products? How do we engineer from first principles better products that sell and do better? Standardization, regulatory inputs for debris control and removal. With all kinds of people in space, there's going to be a collision. Who handles the fender benders? Which there is no such thing as a fender bender in space, mind you. Other applications from other departments. You can imagine one of the things I studied as an undergraduate was arms control and verification. You could imagine non-governmental organizations looking at a constellation of CubeSats for a 21st century version of Eisenhower's open skies policy. Resources in coordination with other parts of California government, snow and fire sats, environmental management, etc. Space business incubator, connection of pure and applied research, outreach and public education. The Institute could do any of these, all of these, a subset, a superset, and be wildly successful. And I think that industry would want to engage both to contribute and to take from such an institute. So that was the idea as I made it, and I think I almost made it in my 5 minutes. I know I made it in my 3 slides.
Thanks, John, and also special commendation for sticking to 3 slides. I think that's worth mentioning. That was really neat. That was really, really neat. Questions or comments?
I think John answered part of what Andre started in his comments earlier. What are you expecting to accomplish? So I think, I don't know how John knows all this already, but that was very good. That was very
like
good.
Right on script. Perfect.
Yeah, I'm a UCLA trained engineer. I've got a good imagination.
And also, I think Jonathan gave us ideas for 10 different courses we could give actually to our students, both to feed them to the industry and actually train people in the industry about space, about big data, about simulations, for example. We specialize in those. Great ideas.
So I think an institute like this, the one-stop shop, the interdisciplinary nature of it, the chance for serendipity. I could give you several examples of major NASA technologies and missions that I've been involved with that started by a serendipitous meeting and a 10-minute conversation and a very quick idea. And so an incubator, a place where this can happen locally, I think can seed many trees, essentially help ensure Southern California's aerospace business well into its 3rd and 4th generations.
Yeah, fantastic. And I'll just highlight, this is the beauty of the wisdom of the crowd. Things that I could only partially answer, John could answer in a much better way than me, and ideas just flowed. So fantastic. Thank you so much. Jeff, would you like to take over?
I'm like Brian. I don't have slides. I will be very quick, but I think and explain what my role is here. First of all, I want to echo Brian's comments about being invited to this, and honored to be amongst all you really, really smart people. I come from the business side, although I'm going to give you a little touch of how I worked in aerospace, and then you'll see, I think, the role that I can play. So I'm the liaison between the Graduate School of Business at UCLA, which is UCLA Anderson, and the Space Institute. And my role there is I run as Brian mentioned, I run the master thesis program for all Anderson students, whether they're fully employed executive MBAs or full-time MBAs, and have roughly 800 students that I'm responsible for. One of the programs that I run is the master thesis is called the Business Creation Option. And I am working currently with the medical school, and we have the biodesign BCO creation program, which has been phenomenally successful. I want to try to duplicate that working with all of you and across your expertise in the departments and schools that you work at Anderson, to try to bring Anderson business students who have an interest in space and in science, and figure out which technologies that you're developing can be commercialized, and then help bring those to fruition. I've had the honor and pleasure to work with Andre in his startup years ago, and he is, I consider him a dear friend. I don't know if he considers me, and he's been a speaker and has come and come to my classes at Anderson. To give you an idea of answering partially also, I think what Andre asked is, I think if we can help bring the new workforce for the future in aerospace and in space, we will accomplish and make a big contribution to the United States. And so between the scientists, the engineers, the business students, we have the ability to hopefully attract and energize the students to want to get into this industry. To give you just a brief snippet of why I'm excited and to what I hope to bring to this. Back in 1998, I was approached to help raise $1 billion for a startup in the space industry. And I had the honor and pleasure to work with, some of you may have known him, he's passed away, George Mueller, who ran the Apollo space program. And he was our CEO, and my job was to raise this money. They were trying to put low Earth orbiting satellites into space without using any government money. Jonathan may not know this, but Northrop was one of our investors in kind, and we raised literally $700 million from individual investors. I left Kistler. It was called Kistler Aerospace. I left Kistler, and because of what I did at Kistler, I was approached by somebody who I didn't know. His name was Vance Kaufman, who was the chairman and CEO of Lockheed Martin, and somebody else who I didn't know, Dan Golden, who was the administrator of NASA. And they asked me to come in, and for 3 years I worked on a program called the X-33 and Venture Star, and wrote the business plan, the financing plan, and the marketing plan because of what I did at Kistler. Dan Golden said, this guy thinks out of the box. We should hire this guy and not a traditional investment banker. So from that, I got really excited about space. Some of you may know these companies. Laura might find this interesting. So I was the very first investor in a startup called Spaceflight, which is now Black Sky, and is going public hopefully July 1st, I pray. My own unicorn that I invested in after, and I started like investing years and years and years ago. So my role here is to try to find the business students who can get excited and work with all of you. A lot of what you guys talked about went over my head, to be honest. So I hope to take what you all develop and help match business students. And then hopefully we can create commercial ventures out of this, and also working with the TDG or the Technology Development Group, get UCLA to benefit from this also. As Laura said, I also didn't go to UCLA. I actually went to USC. Don't yell at me. But I am honored to be.
It's okay. I went to USC also twice.
Okay,
over.
see, we're okay.
Sorry. Sorry.
So no, we always say we're one Anderson. What I found when Miguel and Jacob and the other folks on this call asked me to get involved, Fritz has been. If you don't know Fritz, this guy's phenomenal. By the way, you need to get to know Fritz. When they asked me to get involved, I was astonished of what I didn't know about UCLA, and astonished about all the great things. And it's one of the reasons I wanted Andre to be included in this. I'm stunned at everything UCLA has accomplished in this industry over the years. And we need to do a better job of letting people know about this, letting industry know about this. I'm a big believer in bringing in corporate, like Brian mentioned, corporate venture capital or corporate capital. I hope to be able to make a contribution. I'm honored to be part of this. And I look forward to meeting you all when we get back on campus eventually. I'm over in the Anderson building and we'll be there. And I'm sure Jacob will arrange little groups of us to get together. But those are my prepared comments, basically. And Andre, one of the things I think is success that we create, hopefully, it's not going to be a huge number of entities, but I'm hoping that we can create a couple of entities collaborating with everybody on this call, coming up with some technologies, and then bringing it to commercialization. And if we can look back and do 1 or 2 of these a year, that would be a phenomenal success. So that's how I would have answered your question for the
Yep.
little part that I play.
Right. No, noted. That's good. Appreciate that.
So that's what I would think. That's something I look forward to getting to know all of you. I know I can learn a tremendous amount. I can't promise you I'll understand everything you say, but I'm looking forward to getting to know you in the near future. And thank you, Jacob and Miguel and others, and Fritz for inviting me. I think I finished in plenty of time, right?
You did, and you all have already made a great contribution. We very much thank you for your time and energy that you have given to us so willingly. So thank you very much. So we have a few minutes now before 5:30, and this is just free time to discuss and chat. So if you have any questions, comments, or anything you'd like to throw out, please do it now, or about any of the previous speakers. Yeah, Vasilis, please.
A quick comment following up on the thoughts of Jeffrey here. I don't know if any of you knows that the first idea of a planetary assist, a gravity assist, the satellite was made by a UCLA student who was an intern at JPL. So after his ideas, was a math student, they put him on projects to prove it computationally, and that's how Pioneer was designed. That's how then the Voyagers were designed. So that led to all these missions that it enabled so many planetary missions after that. One student, one idea from math. How can we tap that? Is our goal. How many industries can this create?
I'll say one more word that I wanted to say about following Krishan's talk. Of course, Krishan is a representative of the researcher community at UCLA, which is huge. Krishan himself won't say this, but if you Google Jupiter magnetosphere, you will not find an article without Krishan somehow contributing it or driving it. So, and there are many such amazing researchers. What I was going to say is, in the traditional university administrative environment, researchers are fairly limited in what they're able to do, and which is ridiculous. Our researchers are the best in the world. And so having an institute like this frees up researchers to do things that they wouldn't do in a regular structure, right? To teach, to collaborate with industry. Actually, researchers are very flexible, and they can cut out of their position, reduce it to 0% or some small percentage, go start companies for 2 years, 3 years, 5 years, whatever, come back to their position. That kind of flexibility, I think, is very unique to the researcher community at UCLA. It gives us great potential as well. So I wanted to mention that.
The one other thing I'll just bring up, which is always a sensitive subject. We want to get ideas from all of you to figure out how we should take this forward, and part of that is to figure out how we capitalize that and how we utilize the funds. So we have no preconceived notions. We have several centers at Anderson that are funded through contributions from people. So if you guys have ideas of, and then if we get some funds, then we can do more for the community and do more for industry. So just something to think about. Plant the seed, and I look forward to tomorrow's talk and meeting and hearing from most of you, or a lot more of you. And God bless America and UCLA, right?
Yeah.
And Fritz, thank you. If you all don't know it, he's been instrumental behind this. So he's very quiet, but he's very powerful.
Very much a catalyst.
Yeah.
I think. Certainly for this workshop, it's completely Fritz.
And you're on time. I don't believe it. Wow.
Right. See, we're efficient already.
Right.
Miguel, did you want to say a few words before we close?
You're supposed to keep the closing remarks, but what I want to say is that this has been a remarkable, almost 90 minutes now, and that this is very exciting. Obviously, I think the structure of this workshop has been fantastic. Today, talking about the science, who we are, and our aspirations to really become a really important partner of the industry in Southern California, and how we are very open to entrepreneurship. So tomorrow we will hear about an aspect that we've been talking a lot about, which is our fundamental vision, right? Which is education, workforce development, and interactions internally amongst us, and what's the current landscape on technology development at UCLA. So tomorrow we'll have Dina Lasovsky from our technology development group telling us a little bit about that. So I think we have a really nice integrated vision for the workshop. And I think, this is very exciting, I think. So I can see already a lot of good things coming along. I really love, John Arenberg's vision, the 10-year report, I think puts it right on target. Thank you very much. So yeah, so it's you now, Jacob.
Wonderful. All right, well, let me be very respectful of everyone's time and close in the next minute. But I think you can see where we're going with this. We have top-notch science. We have huge potential for science discovery. The science pushes the engineering, and we kind of demand of our engineers that they give us better propulsion, instruments, spacecrafts. We push the technology. And if there's a very easy bridge from technology to commercialization, to entrepreneurship, that's the unique part. It's not exactly unique. Other people are trying this. What's unique is that we're embedded in Southern California in the aerospace industry. We're right here in this ecosystem that we can interact with very readily. There's labs and companies and the VC community is all around us. And so this is what we want to do. We want to figure this out. How do we do this in the right and in the most effective and the most relevant way to serve our mission, get people educated into the middle class, get industry, people that are just, extremely effective from day one. Like Vasilis's 250 students coming out of a mission that is this big, right? Done kind of from converted classrooms in the basement of his building. That's how effective you can be. So that's the vision. We are so excited. You can see the beginnings of this kind of the wisdom of the crowd starting to take effect. And I think we're going to have more of that tomorrow. So with that said, it's 5